Hello, my people. Good morning, good afternoon, good evening. This is Tasien. I'm happy to be here again. Welcome to Mathematics Analytics. You mean a lot for us. Your likes, your sharing, your comments. This means a lot for us. Thank you once again. In today's video, I'm going to solve this question as you are already seeing it on the screen. It's question number 16 of section B in the national examination that was done last year in Rwanda, NESA's exam. And it was for grade 2 students in many options. Those options that are doing the Mathematics 2 exam. So, this solution is for you if you are preparing for your exam this year or next year. So teachers, remember to share this video to your students for them to get ready for the exam. I hope you are going to enjoy today's presentation. If you have any question, write the question in the comment section, or if you have anything to add to my solution, write it also in the comment section. Without delaying, let's start. The question says, consider the function f defined by f of x equal to ln of 1 plus x. A. Determine the domain of definition and the range of f. Write down the first four non-zero terms of the MacLaurin expansion of ln of 1 plus x in ascending powers of x. And C, without using the hospital rules, evaluate this limit. And D, from the results in B above, find the approximation to the integral. We calculate these integrals based on the result that we are going to get in B. And then in E, write down the power series of this function as it has been given, and then determine the radius and the interval of convergence of these series. All right. So let's start. Let's see how we can deal with this question. First of all, we have our function. I'm going to write it down. We have our function f of x equals ln of 1 plus x. And in A, we are asked to find the domain of definition and the range of this function. To find the domain of definition, we need to know the condition of existence of this function. First of all, we have natural logarithm, and the natural logarithm is only computed for positive numbers. So the condition of existence of this function is that 1 plus x should be greater than 0. So this implies that x should be greater than -1, and therefore the domain of definition will be equal to what? Domain of definition of a function f will be equal to the interval which is greater, any number which is greater than -1. So it's from -1 excluded, then up to plus infinity. Up to plus infinity. This is the domain of definition. And how do we get the range? This is the domain definition, but we are also asked to compute the range of this function. But how do we get the range? Normally, to get the range of this function, we compute the limit. We compute the limit of extreme values, then limit of this function when x tends to -1. Limit of ln of 1 plus x when x tends to -1. So you can see that this will be equal to ln of 0, which is it tends to -infinity. And the limit when x tends to plus infinity of our function ln of 1 plus x, this will tend to plus infinity. So then these two implies that the range of our function f will be equal to this interval from minus infinity to plus infinity. So this was A. In B, we are asked to write down the first four non-zero terms of the MacLaurin expansion of our function in ascending powers of x. MacLaurin expansion. We have our function. Let me take another page. Yes, we have our function. We are at B. We have our function f of x equal to ln of 1 plus x. And the MacLaurin expansion of this function, f of x, it is a polynomial of the form f of 0 and plus f derivative of 0 times x or over 1, of course, and let me write it times x power 1 over 1 factorial and plus f second derivative of 0 times x squared over 2 factorial and plus and so on plus f derivative of order n in 0 times x power n over n factorial. So this is the general form of the MacLaurin expansion of n given function f of x. So now having our function f of x equal to ln of 1 plus x, what do we have to do? First, we have to compute f of 0. F of 0 will be equal to what? This is ln of 1 plus 0. And this is equal to ln of 1, which is equal to 0. And next, what do we have to compute? We have to compute the first derivative of f in 0. So let's first compute the first derivative of our function. First derivative of our function will be equal to, this is ln of 1 plus x derivative. The derivative of this is equal to 1 plus x derivative over 1 plus x. And this is equal to 1 over 1 plus x. This is the first derivative. And then next we compute the first derivative in 0. So for x equal to 0, the first derivative for x equal to 0, this will be equal to 1 over 1 plus 0, which is equal to 1. And next we have to compute this value, f second derivative in 0. First we compute the second derivative of our function, and the second derivative is equal to the derivative of the first derivative. So it's the derivative of 1 over 1 plus x, the derivative of this function. And this is equal to, this is minus 1 over 1 plus x squared. Over 1 plus x squared. Yes, and then we compute the second derivative in 0. Yes, and this will be equal to what? This will be equal to minus 1 over 1 plus 0 squared. So this will be equal to minus 1. Yes. And the next, what do we have to do? Next, what we have to do is to compute the third derivative, the first derivative of our function. So what do? We compute the derivative of the second derivative, and the second derivative we have found it to be minus 1 over 1 plus x squared. So the third derivative will be, the third derivative of our function x will be equal to the derivative of minus 1 over 1 plus x squared, the derivative of this function. I'm not going to compute it in detail, but if you compute it in details, you will get that this derivative will be equal to 2 over 1 plus x power 3. And what do you do next? You compute the value of this derivative when x is equal to 0. So this will be equal to 2 over 1 plus x. X is equal to 0, so then over 1 plus 0 over 1 plus 0 power 3. So this is equal to 2. And next, what do we do? Because we have been asked to compute 4 terms. So then let's compute the fourth derivative. And the fourth derivative of this function, fourth derivative of our function will be equal to the derivative of the third derivative. So the derivative of 2 over 1 plus x power 3. Yeah, again, when you compute this derivative, you will get minus 6 over 1 plus x power 4. And next, what do? We compute the fourth derivative when x is equal to 0. So this will be equal to minus 6 over 1 plus 0 or power 4, which is equal to minus 6. Yes, so what do we have? Let me use another color here. Yes, we have this minus 6 at the fourth term and 2 at the third and minus 1 at the second derivative. And what else do we have? And we have 1 at the first derivative, and we have 0 when the function is not differentiated. So then we are going to insert all these values in this MacLaurin expression here, in our MacLaurin expression here. So if we insert the values that we have obtained in this MacLaurin expression, so here f of 0 will be equal to 0 here, and this is equal to 1, this value, and again this value is equal to minus 1, and then at the third we will have 2, and at the fourth we will have minus 6. So let's do it a bit down here. So we will have, let me write it down here, we will have f of x equal to 0 and plus, was it the first one, was it 1 or minus 1? I don't remember my brain. Yes, it's 1. Yes, the first one was 1, then plus x, and the next one was minus 1 minus x squared over 2. 2 factorial is 2, and the next one was 2, then plus 2 times x power 3 over 3 factorial, and the next is minus 6 and times x power 4 over 4 factorial. So this is the fourth terms, non-zero terms, because the first term is 0 here, so this one is 0. Then the first non-zero is this one, the second, the third, and the fourth. So if I remove these factorials, what am I going to get? The final answer, the final Taylor expression will be, f of x will be equal to x minus x squared over 2. Then 3 factorial is equal to 6. Then 2 simplified by 6, we will have 3 remaining at the denominator. Then plus x power 3 over 3. And 4 factorial. This 4 factorial is equal to 24. And then 6 over 24, this can be simplified then to remain with 1 over 4. Then what do we have? We have here minus x power 4 over 4. So this was the asked MacLaurin expression of our function ln of x our function ln of 1 plus x. Yes, that was it. Next, in C, we are asked to evaluate the limit of this function. This is the ln of 1 plus x over x. Our function f of x over x when x tends to 0 without using hospital rule. Okay, so what do? We already know the Taylor expansion of our function. In C, let me take this a little bit up. Take this a little bit up. All right. Yeah, we have in C we are asked to compute the limit when x tends to 0 of ln of 1 plus x over x without using hospital rule. All what we know is that this function in the numerator ln of 1 plus x, was our function f of x, and we already know its Taylor expression, so we can replace its approximation. So we can consider ln of 1 plus x to be approximately equal to this Taylor expression that we have computed. Then approximately equal to x minus x squared over 2 and plus x power 3 over 3 and minus x power 4 over 4. So if we approximate it this way, then the limit when x tends to 0 of ln of 1 plus x over x will be equal to limit when x tends to 0 of x minus x squared over 2 plus x power 3 over 2 minus x power 4 over 2. Oh no, sorry, I'm writing something wrong here. It's over 3 and here it's over 4. Yes, over 3 and over 4, then all over x. Yes, so if we divide by x all these terms, what do we get? This is the same as the limit when x tends to 0 of x over x, this is equal to 1, and x squared over 2 over x, this is minus x over 2, this is x. Let me write it well. We are not allowed to write something which is not clear. So then x over 2, then x power 3 over x, this is plus x squared over 3 and minus x power 3 over 4, and we take x tend to 0. So if x tend to 0, what are we going to get? Here we have 0 and here 0 and here 0. So then all this part will become, this will become 0. All this term will become 0. So then the limit will be equal to 1. So this is equal to 1. Yeah, so the limit was equal to 1, and that was it. Yes, next let's continue. Next it's D. In D we are asked to compute this integral. So then we have already computed this, so we are going to compute this, and I think it's going to be easier. So let's go. Yeah, we already have in D we are asked to compute integral from 0 to 1 of ln of 1 plus x over x dx. What do? We have to find something to replace by this one, and we have already computed it somewhere. Let me use another color. This one we have computed it to be equal to this one. So computing this integral of this function is the same as computing integral of this one. So you see, the function was not that difficult, just replacing. So this will be equal to integration from 0 to 1 of 1 minus x over 2 plus x squared over 3 and minus x power 4 over 4. So this integration, I think it's not that much difficult for everybody. So this will be equal to this is integration from 0 to 1 of 1 dx and minus 1 over 2 integration from 0 to 1 of x dx and plus 1 over 3 integration from 0 to 1 of x squared dx and minus 1 over 4 integration from 0 to 1 of x power 4. Was it power 4 there? This is this is a mistake. We have power 3 here. So this should be power 3, not power 4, power 3. So let me correct it. So here we should have 3 here. Yes. Yes, this is power 3 and power 3 here. Yes, dx like this. Alright, then this will be equal to, if we integrate this one, this will be x. Then we evaluate it from 0 to 1 and minus 1 over 2. Integration of this one, this is 1 over 2 x squared, and we evaluate it from 0 to 1 and then plus 1 over 3, and this is that integration will be this is 1 over 3 and x is power 3. Yes, from 0 to 1 and minus 1 over 4, and that integration is 1 over 4 and x power 4. Alright, and from 0 to 1. Yes. Alright, so this will be equal to what? This will be equal to 1 minus 0 and minus x squared power 1. This is 1, then 1 over 4, 2 times 2, then minus 1 over 4, minus, then plus 0, and 1 over 9 plus 1 over 9. Yes, and plus 0, of course, and minus 1 over 16 minus 1 over 16 and minus 1 over 16 and times x power 4. Oh, x is x is 1 minus 1 over 16 and minus plus 0. Yes, here we have minus. So anyway, so this is equal to 1 minus 1 over 4 and plus 1 over 9 and minus 1 over 16. So if you compute this will give us 1 over 105 over 144, and this is approximately equal to 0.7986, and this was the last answer, and that was it. Next, in E, we are asked to write down the power series for our function ln of 1 plus x. Write down the power series. Yes. Let's see. Let's take this one a little bit up. I need this hand. Yes. And I think you remember let's first see it up here. You remember the Taylor series that we have computed. This series, this one, this is series, or this one, f of x equal to x minus x squared over 2 plus x power 3 over 3 minus x power 4 over 4. So then using this one, we are going to write the power series of our function ln of 1 plus x. So let's go down here. Yeah, what am I doing? All right, yes. So we have our function in E. Is it E? In E, we have our function f of x equal to ln of 1 plus x. And we have written its exterior expression. The first four non-zero terms was x and minus let me write x well. It was x minus x squared over 2 and plus x power 3 over 3 and minus x power 4 over 4. And if we continue, see that we will have plus x power 5 over 5 minus x power 6 over 6 plus and so on and plus. If we try to generalize, so you see here in front of, let me use this, in front of x here we have 1, and 1 is like minus 1 power 2, and here we have power 1, so and 2 is equal to 1 plus 1. Yes, and in here we have minus 1. Minus 1 can be equal to minus 1 per alright, minus 1 can be equal to minus 1 power 3, which is equal to 2 plus 1, and so on. If we try to generalize this, so this will be minus 1 power n plus 1 and x power n and over n. So you see, when we have x power 2, we have over 2, x power 3 over 3, x power 4 over 4, x power 5 over 5, x power 6 over 6, then over n. And this minus 1 to alternate with plus and minus, plus and minus. So the general term is this one. And if we try to generalize this, we can say that our function f of x is equal to the sum n equal to 1 up to infinity of minus 1 power n plus 1 times x power n over n. And this is the power sum that we have been asked to write down. And that was it. And finally, we are asked to determine the radius and the interval of convergence of these power series that we have just computed. Yeah, so what are we going to do? How are we going to compute this radius and the interval of convergence? So one way to do that is to use the ratio test for convergence. The ratio test for convergence. We have our series there. Okay, let's take this one a little bit up here, and then f. We are going to compute the radius and the interval of convergence for this series. So what do? We are going to use the ratio test. The ratio test, how does it work? We have to compute first the ratio between two consecutive terms. Let's say the ratio between the term number n plus 1 and the term n. So this ratio and its absolute value, and we compute its limit when n tends to infinity. So this should be less than 1. So what do we do? So the term the term number n will be equal to what? This term number n will be equal to minus 1 power n plus 1 power x power n over n. Yeah, as it is given here. So, but what about the term an plus 1? The term an plus 1 will be equal to minus 1 power n plus 1 plus 1 and x power n plus 1 and over n plus 1. And this is the same as minus 1 power n plus 2 and x power n plus 1 over n plus 1. And what if we compute the ratio between these two consecutive terms? The ratio between these two consecutive terms, an plus 1 over an. This ratio will be equal to minus 1 power n plus 2 times x power n plus 1 over n plus 1, and this should be divided by, let me do it this way, divided by minus 1 power n plus 1 times x power n over n. Yeah, so dividing these two, what are we going to get? Let me take these ones a little bit up so that will be very clear to everybody. Yes, all right. So this is equal to minus 1 power n plus 2 times x power n plus 2 and over x, not x, over n plus 1 over n plus 1 and times what? Times n and over minus 1 power n plus 1 and times x power n plus 1. And you can see that we can simplify. How are we going to simplify? Let me take another color. This minus 1 power n plus 1 and this minus 1 power n plus 2, we are going to simplify so that here we will remain with power 1, because here it's n plus 2 is the same as n plus 1 plus 1. Then we simplify n plus 1 with n plus 1, then we remain with 1 here. Then minus 1, this will be equal to, I take another color, let's take this. Then this will be equal to minus 1 and power 1, yes. And then next, let me take this again. And then next, x power 2, x power n plus 2 and x power, oh, let me take another color so that we are not going to be confused which color maybe. Let me take maybe this green. All right. And then x power n plus 2 and x power n plus 1. If we simplify, here we remain with 1 again. Then we have x power 1, and then times this one. Then the remaining one is, use this purple, yes, is this n and n plus 1. Then times n over n plus 1. All right. And let me take my black color. So then this will be equal minus 1 power 1, this is minus 1, and then x power 1, this is x minus minus x, and then times n over n plus 1. Yes, this is this ratio. And then what about an plus 1 over an, then absolute value? Then this absolute value will be equal to absolute value of minus x times n over n plus 1. This. So this will be equal to this is equal to absolute value of x, all right, and times n over n plus 1. All right. And then if we introduce the limit to this ratio, what are we going to get? And finally, the limit limit when n tend to infinity of this ratio absolute value of an plus 1 over an. This will be equal to limit when n tend to infinity of absolute value of x times n over n plus 1, and this is equal to absolute value of x, because this is absolute value of x does not contain n, so we can isolate it, then times limit when n tend to infinity of n over n plus 1. So we have a polynomial in the numerator in n, and on the numerator also we have a polynomial in n, and the same degrees. We have the same degree on the denominator and on the numerator. So then this limit will be the coefficient in the front of here, this is 1, and the coefficient here, this is 1 over n. So then this limit will be equal to 1. So then we have absolute value of x. Alright, and then finally we have limit when n tend to infinity of our ratio an plus 1 over an is less than 1 if and only if absolute value of x is less than 1. And this implies what? This implies that the radius of this series, so therefore what do we have? Therefore we have that the radius of our series, this sum up to infinity minus 1 power n plus 1 x power n over n is r equal to 1. So this is the radius. So how do we know now the interval of convergence? To know the interval of convergence, we have to study this one, the convergence of this. We have absolute value of x is less than 1. So this means that minus 1 is less than or equal to x, and less than or equal, less than or equal to, it's not less than or equal, it's less than yeah, alright, less than x and less than 1. So what do we have to do? We have to study the value when x tend to minus 1, what our series becomes, and when x tend to 1, what our series becomes. Okay, you can see that at x equal to 1, our series will become summation when n tend to summation from n equal to 1 up to infinity of minus 1 power n plus 1 and times c minus 1 power, not minus 1, x is equal to 1, not minus 1, times 1 power n over n. So this is equal to summation from n equal to 1 up to infinity of minus 1 power n plus 1 times 1 over n. So you can see that this is the alternating harmonic progression, and this harmonic progression, alternating, of course, alternating positive negative, alternating harmonic progression. It is a convergent progression, so it converges. So at x equal to 1, our series converge. We have convergence here, converges, our series converges. But what about at x equal to minus 1? At x equal to minus 1, our series will become summation when n tend to goes from 1 up to infinity of this will cancel to 1 over n, and this is a harmonic progression, and the harmonic progression diverges. Here we have divergence, so this diverges. So since at -1 the series diverges, but at 1 the series converges, so this means that the interval of convergence will be which interval? The interval of convergence, interval of convergence is, it will be from -1, but this one is excluded. You can write it this way: excluded up to 1 included, because at 1 it converges. You can write it this way, or you can also use this open like this, or you can also write it this way, whatever you want to write. But that was the interval of convergence. 1 minus 1 is excluded. So that was it for this equation, and I hope you have learned a lot from me. If you have any question, don't forget to write your question in the comment section. And if you have anything to add to our solution, also write it in the comment section. Yeah, but don't worry, the questions will be easy to handle, and I hope you will pass your exam, and I wish you good luck with your exams. Thank you for watching, and hey, if you have not yet subscribed to this channel and you wish to see more videos like this in the future, remember to subscribe and turn on the notification bell so that you will get notified anytime we upload any video. And remember to share this video to your network. See you for next time. Hopefully we'll be solving the question number 17. See you. Bye.